Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 11, container with most water. We're basically given an array called height and it has a bunch of numbers in it. And these numbers actually represent these columns that we have here or these lines here. So for example, here we have number 1 inside of our height array. And as you can see, we have 1 here. And then we have 8, and this is the 8, and then we have 6, and this is the 6, and so on and so forth. And we basically gotta calculate the most amount of water we can hold between two specific lines or columns. But in reality, we're actually calculating the area of a rectangle because as you can see, this shape that's representing the water is actually a rectangle. And these heights that we have here are actually the height of our rectangle. And the distance between them is the width. So long story short, we gotta calculate the biggest rectangle we can fit here. So for example, between these two, we can actually fit a rectangle, but it's not gonna be the biggest. The biggest is this one between these two lines here. As you can see, it's clearly visible. All right, let's solve this together. I will not finish this video until I make sure you fully understand how to solve this problem once and for all. So we have our height array here, and we also have the chart that was given to us. And as we discussed, these numbers actually represent the height here. So this is the 1, as you can see, 1, 1, 8, 8, and 6, 6. And we gotta calculate the area of this rectangle here. And for calculating the area, we basically have to multiply this height by the width, and our height is basically these numbers that are given to us, and our width is the distance between our two columns. All right, so first of all, I'll tell you how the algorithm would work, and then I'll visualize the whole algorithm from the beginning to the very end, so you can actually see how the algorithm is working, basically. Alrighty, so the first thing that we need is obviously a result variable, so we can actually return the maximum area that we're gonna actually calculate. And then we're gonna need a left variable, which is gonna be equal to 0, and it's gonna point to the very first number in our array, which is this one here, because the index of this number here is 0, so left is pointing to this number here. And then we're gonna have a right variable that's gonna be equal to height.length minus 1, meaning it's gonna be pointing to the item at the end of our array. So the last item in our array, which is this 7 here, is what our right pointer is pointing to. We're basically done with the variables, so let's move on to the algorithm. We're gonna have a loop here. In our loop, we're gonna first calculate our width, and width is gonna be equal to right minus left. As you can see here, if our right pointer is pointing to this line here, and our left pointer is pointing to this line here, their width is gonna be right, which is ahead, so it's gonna be a bigger number. So right minus left is gonna give us the width between these two. And that's why our width is gonna be right minus left, because even if you actually take a look at it here, our left is this one here in the beginning, and then our right is actually pointing to this number here. So if we wanna calculate the distance between the two, we're just gonna subtract the value of our left pointer here from our right pointer. So for example, our right pointer is equal to height.length minus 1, and this is gonna be 8 because the index of this number here is actually 8. So 8 minus 0 is still gonna be 8, so width is gonna be 8. This is just a simple example because I'll visualize the whole process. And then we're gonna have our current area, which is gonna be equal to our width that we actually calculated here, multiplied by the minimum height of the number that our left pointer is pointing to, or the number that our right pointer is pointing to. Now, let me explain this. As you can see, we're getting the minimum value between these two. So for example, if our right pointer is pointing to this 8 here, and our left pointer is pointing to this 2 here, for calculating the current area, meaning the rectangle between them, we're gonna actually use the minimum number, which is this 2 here in our example. And that's because no matter how big one of the columns is, it's always gonna be limited to the height of the other one. As you can see, even though this is 8 and this one is 7, it doesn't really matter because if we actually pour more water inside here, it's not gonna stay inside because this line has the height of 7. Therefore, when we're actually calculating the current area, we make sure that we only multiply the minimum height, not the maximum. Alright, now that we have our current area, we're gonna actually compare it to our previous results. And if the new area that we've actually calculated just now is bigger than our result is gonna be equal to the new area, else result is gonna stay the same. And then our final step, we're gonna have this if statement inside of our loop, and we're gonna say if the number that our left pointer is pointing to in our height array is smaller than the number that our right pointer is pointing to in our height array, increment left. So for example, if our left pointer is pointing to this 2 here, and our right pointer is pointing to this 8 here, because this number is smaller than this 8 here, we're gonna actually increment left. So in the next round, left is gonna be pointing to this 5 instead of this 2. And if that's not the case, we're gonna decrement right. So for example, if our left pointer is pointing to this 8 here, and our right pointer is pointing to this 7 here, because 7 is smaller than 8, we're gonna decrement our right pointer and it's gonna be pointing to this 3 in the next round. And that's literally it. Then at the end, we're gonna return our result. Now let's visualize this whole process. Alright, so as we discussed, this right is gonna be equal to 8 because we only have 8 numbers here, and right is gonna be equal to 8 because it was actually equal to height.length minus 1, and the index of this number is 8, so right is gonna be 8. Now let's start the loop. As you can see, we're actually in the first round of our loop. In our first round, left is gonna be equal to 0, so it's gonna be pointing to the first number in our array, which is this one here. And right is gonna be equal to 8, so it's gonna be pointing to the last number, or the number with the index of 8 in our array, which is this 7 here. Alright, so first we're gonna calculate our width, and it's gonna be equal to right minus left. So let's do that. Right is 8, left is 0. So right minus left is gonna be 8, meaning our width is 8. Then we're gonna calculate our current area. So our current area is gonna be equal to our width, which is this 8 here that we actually calculated above, multiplied by the minimum value between the numbers that our pointers are actually pointing to. So our left pointer is pointing to 1, and our right pointer is pointing to 7. So we're gonna have 1 and 7 here, and we're gonna obviously choose the minimum, which is 1. So our current area is gonna be 8, which is our width, multiplied by 1, and it's gonna be 8. Now that we have our current area, we're gonna compare it with the previous results. So let's do that. Result is gonna be equal to the maximum value between current area and result. So max between 8, which we calculated here, and 0, because we're actually in the first iteration of our loop, and result is 0. So result is gonna be equal to 8, so let's do that. And then at the end, the number that left is pointing to is 1, and the number that right is pointing to is 7. So 1 is less than 7, therefore we're gonna increment left, just like we said here. So let's do that. Now left is equal to 1, and now left is pointing to the number with the index of 1, which is this 8 here. And then we're gonna enter our second round. In our second round, we're gonna calculate our width again, which is gonna be equal to 8 minus 1, because right minus left, and right is equal to 8, and left is equal to 1, so 8 minus 1, it's gonna be 7. This is our width. Then we're gonna calculate our current area, which is gonna be equal to 7, which is our width, multiplied by the minimum value between 8 and 7, because our left pointer is pointing to 8 and our right pointer is pointing to 7. So 8 multiplied by 7, because 7 is our minimum value, and it's gonna give us 49. This is our current area. Then we're gonna compare our current area with our result. So we're gonna say choose the maximum number between our current area, which is 49, and our result, which is 8. So maximum between 49 and 8 is 49. So let's update our result like so. Then we're gonna check the number that our left pointer is pointing to, which is 8. And then we're gonna check the number that our right pointer is pointing to, which is 7. Is 8 less than 7? No, so we're gonna decrement right, like so. 8 is bigger than 7, so this condition here is not gonna be true. Therefore, we're gonna fall inside the else, and we're gonna decrement right. So let's do that. Right is 8, it's gonna be 7, and then it's gonna be pointing to this number here, because we just changed the value of right. So currently, right is equal to 7, and it's pointing to the number with the index of 7, which is this 3 here. And then we're gonna enter our third round. We're gonna do the same thing, so we're gonna calculate our width, which is gonna be 7 minus 1, because as you can see, right is 7 and left is 1. So our width is gonna be 6. Then we're gonna calculate our current area. Our current area is gonna be 6, which is our width, multiplied by the minimum value between these two. As you can see, 8 and 3. We're gonna pick 3 because that's the minimum, and then we're gonna calculate our current area, which is gonna be 18, and then we will compare this 18 to the previous values of result. So let's do that. We gotta choose the maximum value between current area and result. So maximum between 18 and 49, that's gonna be 49. So result is not gonna change. And again, because the number that our left pointer is pointing to, which is 8, is not smaller than the number that our right pointer is pointing to, which is 3, we're gonna fall inside the else, and we're gonna decrement right. So as you can see, 8 is bigger than 3, we're gonna fall inside the else, and then we're gonna decrement right. So let's do that. As you can see, right is 6 now, and it's currently pointing to this number here, which is 8. Now let's move on to our next round. We're currently in our fourth round, so let's do our calculation again. Our width is gonna be right minus left, so 6 minus 1, which is gonna be 5. Then we're gonna calculate our current area, which is gonna be equal to 5, multiplied by the minimum value between 8 and 8. So we're gonna pick one of these 8, and then we're gonna multiply it by 5, and it's gonna give us 40. Then we're gonna pick the maximum number between our current area and result. So our current area is gonna be 40, and our result is 49, as you can see here. So we're gonna pick 49, and our result number is not gonna change. And then at the end, height of left, or the number that our left pointer is pointing to, is 8, and it's not less than the number that our right pointer is pointing to, which is also 8. So we're gonna fall inside the else, and then we're gonna decrement right once more. As you can see, 8 is equal to 8, so we're gonna decrement right. So let's do that, and now right is pointing to this number here. Now we're gonna enter our 5th round. Let's do our calculation again. Our width, which is equal to right minus left. As you can see, 5 minus 1, it's gonna be equal to 4. Then our current area is gonna be equal to 4 multiplied by the minimum value between 8 and 4. That's gonna be 4. So 4 multiplied by 4 is 16. We're gonna compare it with our result. So we're gonna pick the maximum number between our current area and our result. So that's gonna be maximum value between 16 and 49. We're gonna choose 49, so result is not gonna change. And then our left pointer is pointing to 8 and our right pointer is pointing to 4. So as you can see, 8 is not less than 4. Therefore, we're gonna fall inside the else and we're gonna decrement right once more. Now right is equal to 4 and it's pointing to the number with the index of 4, which is this 5 here. And then we're gonna enter our next round, which is gonna be our 6th round. We're gonna repeat the same thing. We're gonna calculate our width, 4 minus 1, so it's gonna be 3. Then we're gonna calculate our current area. It's gonna be 3 multiplied by the minimum value between 8 and 5, so it's gonna be 5. Therefore, 3 multiplied by 5, it's gonna give us 15. We gotta pick the maximum value between our current area and our previous result. So that's gonna be 15 or 49. We're gonna pick the maximum number, that's gonna be 49. So our result is not gonna change. And our left pointer is pointing to 8 and our right pointer is pointing to 5. So 8 is not less than 5. Therefore, we're gonna fall inside the else and then we're gonna decrement right. So let's do that. Right is now equal to 3 and it's gonna be pointing to this number here. Let's move on to the next round, which is gonna be our 7th round. Let's do our calculation again. So width is gonna be 3 minus 1, 3 minus 1, right minus left. That's gonna be 2. Let's calculate our current area. It's gonna be 2 multiplied by the minimum value between 8 and 2. So that's gonna be 2 multiplied by 2, and that's gonna give us 4. So this is our current area. Now we gotta choose the maximum value between our current area, which is 4, and our result, which is 49. So we're gonna choose the maximum number, which is 49, and our result is not gonna change. And then the number that our left pointer is pointing to is 8, and it's not less than 2. Therefore, we're gonna fall inside the else, and we're gonna decrement right. So let's do that. Now right is 2, and it's pointing to this number here. And then we're gonna enter our next round and repeat our calculations again. Width is gonna be right minus left, so 2 minus 1, it's gonna be equal to 1. Our current area is gonna be 1 multiplied by the minimum value between 8 and 6, so that's gonna be 1 multiplied by 6, and it's gonna give us 6. Then we're gonna calculate our result. Our result is equal to the maximum value between our current area, which is 6, and the previous result number, which is 49. So let's pick the maximum value between these two, which is gonna be 49 again. Therefore, we're not gonna update this number here. And because our left pointer is pointing to this 8 here, and our right pointer is pointing to the 6 here, we're gonna again fall inside the else. So we're gonna decrement right. As you can see, right is gonna be equal to 1 and left is gonna be equal to 1. So they're pointing to the same number. And we're gonna break out of our loop because the condition for our loop here is gonna be while left is less than right. And as you can see, left is equal to 1 and right is equal to 1. So left is not less than right. So we're gonna break out of our loop and return our result here. And as you can see, our result is 49. Now let's code this in the simplest way possible. Alright, let's code this. So in the beginning, we're gonna define our result variable that's gonna be initialized to 0. And then we're gonna define our left pointer that's gonna be equal to 0 as well. And then we're gonna define our right pointer that's gonna be equal to height dot length minus 1. Then we're gonna define our loop and we're gonna say while left is less than right, do the following. So we're gonna first define our width variable that's gonna be equal to right minus left, simple as that. And then we're gonna say let current area be equal to width multiplied by math.min the height of left and the height of right. So our width multiplied by the minimum value between the number that our left pointer is pointing to inside of our height array and the number that our right pointer is pointing to inside of our height array. And then we're gonna say result is equal to math.max current area and our result. So result is gonna be equal to the maximum value between these two here. This is the current area that we just calculated and this is the result itself. And then at the end, we're gonna say if height of left is smaller than height of right, left plus plus, so we're gonna increment left if the value that our left pointer is pointing to is less than the value that our right pointer is pointing to, else right minus minus, so we're gonna decrement right. And believe it or not, that's it. So we're gonna exit our loop and we're gonna return our results. This is all of our code, and now let's run it. Let's see if it's gonna work. It would be really funny if it didn't. Yep, accepted, as you can see, both of the cases. Now let's actually submit it and see if we're gonna pass it. Moment of truth. There we go. Accepted, and it's actually beating 84% of all of the other submissions. Let's analyze our time complexity. Because we only have one loop, we're gonna have the time complexity of O of n. Thanks for watching. Don't forget to like and subscribe.